Hello, 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 hello. Welcome, folks. Welcome, friends. I'm so excited for you to join us today on our seminar. My name is Lauren, and joining me today is a friend, Tarek. I'm so excited to have you. Thank you for being a guest on Substrate Seminar.
Thank you for having me. Very excited to chat about our tools and what we build and help get people onboarded or intro
Dive
to
into it.
what they
Let
could
me
use.
tell us about yourself. What do you do at Parity, and how'd you end up on this tools team, and what does that mean to be on the tools team, and all those things?
Yeah, of course. So actually, I joined Parity about almost 2.5 years ago. I had a friend who worked here, and we both love cryptography. So he kind of introduced me to the tools team, and it kind of went from there. So I am an engineer at Parity. I work on tools specifically. I um, I love it very much. We have a lot of outreach, especially with exchanges and parachains, which is pretty cool. And yeah, it's pretty exciting to work on this stuff every day. And yeah.
I love it. Yeah, I remember. So you and I connected recently. We were working the booth together at Consensus, which is a big event within our ecosystem or within the blockchain space in general. And yeah, your enthusiasm was contagious and captivating. So hence, I was like, you need to get on this show with us. And your team does Friday streams as well. So familiar space, but happy to have you here in this regard. And welcome everyone that is here watching live with us. If you have any questions, please pop them into the chat. So happy to see you all in the space, and yeah, want to be here to not derail necessarily our conversation, but a tangent is welcome. If you have a question about what you're building, we welcome it. So otherwise, let's dive into our topic of today. The title of the episode is Integration Tools Being Built and Maintained. What should we start with? Shall I pull up your what you have prepared for us today?
Yeah, let's dive right into the slides.
Let's do it. Okay, cool. Introduction to tools by the
Cool.
integration tools team.
Yeah, so I guess to give a little agenda around this too,
Sure.
we have three main tools that we focus on the tools team. The first one is Substrate API Sidecar. This has been around the longest and is most familiar to users in the space. It is really focused on just substrate-based chains and being able to configure yourself as a parachain and have individual support, which is really neat.
Mhm.
Um, and then we have TX Wrapper Core, which is an offline signing library. And then we have our new tool, which we're going to give a preview of, which is
Cool.
the Asset Transfer API. And this really focuses on helping make statement and state mine the center for asset management in our ecosystem. So,
Okay, cool. And so you say that sidecar is probably the things folks might be most familiar with. So can we get a reaction in from the audience of those who have heard that, have used it maybe, and feel familiar with, just so that we can kind of level set and get an understanding of that. We will, of course, drop the recording of this onto YouTube later on. So feel free to check that out as well. And yeah, let them live on in perpetuity. But yeah, I would love to know who's familiar with Sidecar or has experience. Always good to kind of understand level set where people are at. But yeah, let's dive in.
cool. So let's see, what is it specifically? It's a stateless REST API that makes it easy to interact with substrate-based chains. It really focuses around using Frame as this directional framework, and we
Okay.
take a lot of the logic and mirror a lot of the logic from Frame itself. And Sidecar is also this big wrapper around Polkadot.js. So we tend to be pretty advanced users of Polkadot.js and leverage all the capabilities that are on
I've
there.
lost you. I wonder if it's my connection on my end or if it's you, one of us. Uh-oh.
Can you hear me
Hello.
now?
No, we lost you for a second. And so viewers, a little inside scoop into my world. You can still hear him. So it was me. Okay, good. I have a thunderstorm rolling in. And so I'm a little terrified that I might drop. But if that happens, keep on talking. Apologies. Okay. Sorry to interrupt you. Keep on. Thank you though for letting me know. um,
No worries at all. So yeah, so basically, we really focus on leveraging all the capabilities that Polkadot.js gives us, and especially the
uh-huh.
fact that Polkadot.js mirrors a lot of Substrate and focuses on Polkadot, West End, and Kusama, and allows us to build these really verbose uh, tools in order to create a pretty simple and seamless REST API for people. Um, and let's dive into the next slide. Cool. So let's just actually talk about the benefits of Polkadot.js and like what it actually does for us, um, or a few things that it really does for us. It allows
Yeah.
us to,
I mean, and actually, even before we go there, like, can you identify what sort of developer you're looking for that or would want and be most curious to use Sidecar? Like, who's
yeah,
that person? Like, what type of dev is
yeah, of
that?
course. So I would say anywhere from exchanges, anywhere from wallets or
Okay,
parachain teams. So with Sidecar, because it's a REST API, you can kind of use it for anything. I mean, from an individual perspective, I would say I use it a lot myself for like validation of things. So
sure,
if there's anything on the chain that I actually want to scrape as I'm being active, like let's say I send a transaction and I want to see it live, I'll scrape the upcoming blocks to ensure I could see what transactions were submitted, is mine in there, etc.
nice.
Um,
Okay, yeah, that
and
helps.
then from a bigger standpoint too, if you're like if you want to have if you're an indexer or anything like that, you can verify your data with Sidecar. So you can just query the chain from Genesis all the way to the head and be able to see everything from blocks, storage to parachain info, auctions, crowd loans, anything you need. So
Love
I
it.
would say the user base is quite wide. You could
No
use it
kidding.
for like your own personal resources, or big companies can use it as well.
Okay, love it. Hopefully that helps for folks that are giving a view or in watching right now. Maybe that's you. Hopefully.
Cool. Um, so a little about like what Polkadot.js gives us as well. So like this first thing is gives us a really active open WebSocket connection, which is pretty neat. And on top of that too, it has these really verbose caching mechanisms that really help for performance. This is really important in Substrate, especially because we have quite a lot of runtimes because of forkless runtime upgrades, which means the metadata changes per runtime, which means every time you are querying something at a different runtime itself, then you'll have to redecorate all of your methods and redecorate your query types. And this is super important so that every time we query a different block within the same runtime, we don't want to redecorate those methods. Let's
Okay.
see, we have a question
Yeah,
here.
we have our first question. If it can be used for on-chain transactions.
So yeah, you could submit transactions via Sidecar. So there is some limitations. So we don't store any client side information or store any information in general,
Mhm.
other than for like reasons or caching. So yeah, you could submit your transaction, but you won't be able to have a subscription to see if that transaction went through. You'll actually have to scrape the incoming blocks to see where that transaction is. So yeah, can you perform on-chain transactions? Yes, you can submit them. You can also watch them via scraping.
Cool.
Um, yeah, so I mentioned this earlier, but like the metadata decoration upon connection connection creation. So every time you connect via the API,
Uh-huh.
the metadata is all decorated, which is super important. So you have all these types and methods that are queryable from any substrate-based node. And this works for parachains as well. So they might have some specific on-chain types, and those will all be generated as well for queries, which is pretty cool.
Sounds
Um,
like oh, Sidecar sounds awesome. Is we've got a first positive note, which is great. Let's
nice.
save that as a metric. I love it.
um, so I guess to build upon that too, there's this really verbose type generation, which mirrors all the nodes types, which is really cool and
Hmm.
super important because a lot of what scale encoded types do is they really reflect exactly what's happening on the frame side of things. And to be able to mirror that in Polkadot.js is super important so we can ensure we have exactly what we expect on the TypeScript side of things, as well as the Rust. And to add to that uh, the building upon the types, you can actually inject your custom types in to Sidecar, which will inject them into
Mm,
Polkadot.js. So if your types aren't really reflected um, exactly on chain, then you can ensure they are by type injection.
yeah.
And then my favorite part of Polkadot.js, which I think is understated quite a bit, it has a full historic support for all runtimes in our ecosystem concerning Polkadot, Kusama, West End. This is super important because before we had V14 and the standardized way of types in our metadata, every metadata version was different or might have some pretty big breaking changes. And Polkadot.js can identify all of them from V0 to V13 and on, which is super important and really
Yeah.
helps us. Yeah. So very cool.
Amazing.
Cool. So that's a little bit about Polkadot.js and
Yeah,
how
that's
it
helpful
helps
to level
us.
set. Yeah.
Cool. So let's talk about how you can run Sidecar at home.
Yeah.
There's three ways really. There's Docker, which a lot of individuals will use just because it's super easy and you can
Hmm.
have your little virtual machine run it. If you're running it on npm and Yarn, you can install it globally, or you can
Hmm.
install it locally, which I'll actually demo the local way. So if anyone wants to hack on Sidecar, they're more than welcome to.
I love it. Do it live. Let's do it while we're watching.
Cool. And then, so just to give a quick intro into the Docker, it's pretty simple. You're just going to pull the latest image of Sidecar, and then you're just going to run it. And these commands are all inside of the README if you need as well. So they're all available. Um, I think,
And the README, I think we have that pulled up.
yeah, so that'll
Here.
be exactly right
Yep.
there.
So yeah, this is where you could grab that command.
Cool. And yeah, it's pretty straightforward. If you don't have an env file attached to it, it'll
Mhm.
automatically grab a local node that you have on your computer. So you might
Got
need
it.
to specify some environment variables.
Yeah, yeah, yeah. Okay, cool.
Cool. So npm or yarn, really straightforward. Just npm install -g is for global, and then yarn global add. Super simple. And yeah, so let's talk about locally.
Okay.
So locally, you're just going to git clone the repository. You'll cd right into that directory. And this little export line, this is the most basic environment variable we have to specify the URL you want to connect to. In this case, the example I have here is just specifying the parity hosted Polkadot node.
Yep.
And then you're going to do a quick yarn install, yarn build, and yarn start. And the reason why we use yarn is the repo itself inherently uses something called yarnberry, which is the enhanced version of yarn. And that package manager is inherent to the repository itself.
Ah, okay.
So,
Okay.
so it's something that needs to be you'll have to have yarn 1.7 to use it on your computer, and then everything is just on the repository itself, so you never actually have to worry about
Okay.
it locally anymore. Cool. So let's talk about some benefits of Sidecar and how it can help you. So first, it has this really clean decoding and sanitization of block data, which means let's say you have a nested extrinsics and these calls
Mhm.
go pretty deep. You don't
Yeah.
actually have to worry about decoding any of that. We can do it all for you, and it's
Okay.
incredibly accurate and it's pretty fast. So that's a nice plus. And we always ensure, as Polkadot.js has the same foundation for this, but
Yeah,
we
yeah,
always
yeah.
actually ensure everything is correct before speed, and then we work on performance second. So we want to make sure all the data you're getting is 100% accurate, and then on
Yeah.
top of that, we build it on performance.
Okay. Okay.
Cool. And then, so we have full historical support too. So history is the most important part to us, especially for an indexer. We want to make sure you can
Yep.
query anything at any time, anywhere. So yeah, you'll have full historical support for any substrate-based node that you use when it has to do with accounts or blocks, etc.
Yeah.
Um,
Awesome.
cool. And we have a really vast option of endpoints for anyone to use as well. And we're really quick on iterating on new endpoints if users need. Um, oh, hey, good morning.
I know. Isn't it fun just like people be like, hi?
Yeah, it's super cool. um, so yeah,
Good.
so if there is an endpoint you want and you don't see it, then we'll definitely be able to iterate on that fast and add it, which is pretty
Okay.
neat.
And what's the process to for that?
Yeah, just open up an issue in our repository
Love.
with that link
Okay.
you posted earlier, and
So
then we'll just probably
straightforward. Isn't that? Oh,
yeah.
that's the dream. Oh my gosh, love.
And usually sometimes
Process
there's
is yeah, that, love it.
yeah, it's a pretty clean process, and sometimes we usually will have a way for um, you to like get the information you need. It might be like a two-step process. You might have to use two endpoints to get the exact data that you want, but if there's a way we can make it easier and aggregate that all into one endpoint, we'll
Ah,
definitely do
okay.
it. As we mentioned earlier, we have like specialized logic to mirror frame. For
Yeah,
example, with our parachain logic, it's really difficult to understand how auctions work and leases. So we actually mirror a lot of the frame logic or anything that comes from Polkadot, and we have written that out in TypeScript for users, so they don't actually have to do any of that themselves.
awesome. I love that. I love a question of etymology. Joshy's asking, where does this name come from Sidecar? Is it the motorcycle sidecar?
Yeah, I don't know where it came from originally in terms of in computer science, but usually if there is some type of API that's going to abut some type of system, it's been referenced as sidecar all the time.
That's a pattern.
Um,
Okay.
exactly, yeah. But as to where that originated from in general, I would imagine probably the motorcycle.
Yes. Yeah, that seems to make sense. Joshy, do you know? Is that a leading question? You never know with him. Okay, cool. Sorry. That's a great you don't know. You know, I have a lot of faith in you. Do you like that? It's like okay, cool. Sorry. I think we're on fast and accurate. Yeah.
Yeah. Oh, cool.
Okay.
So, yeah. So one thing we also do as well, we have a Rust library that we maintain for calculating fees. You can
Uh-huh.
actually use this as well. It's under the library called at Substrate Calc, um, and this is super cool because it calculates all your fees for any extrinsic, and yeah, it's super fast and accurate, and
Love
does
that.
estimations, and it'll allow for all fees to be calculated historically as well,
Oh,
which is
that's
pretty
so
cool.
helpful. Oh my
Yeah.
goodness.
Um, cool. So then let's do the next one. Let's do a little demo really
Love
quickly.
a demo.
Awesome. So let's get this. Oh, wait, why isn't, do I have
No
to,
worries.
interesting. It's not
Here,
allowing me to.
I'll take us off and then you can navigate that. So other questions are welcome. I have drank the Kool-Aid this morning and see all the benefits and think it's super cool. So um, what other questions do folks when imagining how they might use or have if they have in the past as well? Um, and yeah, curiosities abound. Are you ready for me to pull it back up?
Yeah, yeah. For some reason, my mouse is dead. So now we got to use the laptop trackpad.
No, no, no. Oh, yeah. But do you mind making this a bit larger?
Yeah, of course.
Aaron is salty because the other competing term is sidekick, and there could be so many great names if we use sidekick instead. Okay, so we're having a conversation about naming conventionality. Great.
Yes, so actually, a little tidbit there. We are going to do a renaming of Substrate API Sidecar. As to what we're going to do it, we don't know, but we are going to be doing a full rewrite in the future. It's going to
Well,
stay exactly the same and won't be a breaking change for users, but we kind of want to just change the design a bit to be a little more extensible
that makes
for all users that use it. Yeah,
seems like we have a big push or want for sidekick in case anyone is, taking ideas now.
that's awesome.
Okay, yeah, I think that is probably big enough, but folks will let us know if it's too small. But yeah, demo
Cool,
time. And then to answer your question, LA, what is Sidecar? Let's do a demo and see if that gives you the answer.
cool, sweet. So let's clone this really quickly,
Sure.
and then let's just cool. Now that we're inside of Social API Sidecar, let's talk about how we can run this locally so that anyone can hack on this pretty quickly. So ideally, we want to just run a yarn install really quickly, and that should get all our dependencies. And as you can see, using yarn berry is actually super fast,
Hmm.
which is super nice. Oh, sorry. And then from there, we'll do a yarn build.
Build. Yeah.
Cool. And as earlier, let's actually set some environment variables up to make the
Sure.
process a little easier. So let's connect to directly to Polkadot. Oh, sorry.
My stomach is grumbling, and I'm afraid that the mic is going to be able to pick up.
Oh no, I can't hear anything. You're good.
Okay, phew.
Cool. So I believe that's correct.
This is
Yep.
a great question, Least. When is it not? We always do. We're in the business of being like, it's great, it's awesome, use it. But when shouldn't you use it? Oh, I love that.
Yeah, that's a good question.
Right? Yeah, it's thoughtful. It's like it's we get why, but like what are the situations in which there's a case that we shouldn't? It's not recommended.
Yeah, I mean, like, I would recommend not using this as a full server to expose to users as like a public
Right.
free API. Um, there's, and if you do want to use that, you shouldn't be using it with public nodes. You should be using it with private nodes.
Great.
And the reason why we don't want to flood the network with an incredible amount of queries, because Sidecar does send quite a lot of RPC calls.
Yep.
So yeah, I would say if there is a case, you should be using it locally or privately. And if you are going to expose this as a public API, you should really be using private nodes and not public nodes.
There you go. Great. I'm glad we answered that.
Cool. So we set the first environment variable up. Now let's set the second one. So let's do a log level, and let's set the log level to HTTP so we can actually see
what
the transactions are going to, or not transactions, the queries. Cool. So, and then from there, we could just do yarn start.
Simple as that.
Cool. And now we are actively connected, which is super cool. And then we could do a quick, let's do some transactions really quickly to see exactly what it looks like.
Love, yeah.
So let's actually do let's query the head. And as you could see, we're just going to get this. Let me zoom in.
Yeah, I think that needs to be a bit larger. Thank you.
Cool. And then you can see like what the block number is, all the base information such as hash, parent hash. And then we get all of this extra validator information. But what's really neat is the extrinsics on the bottom. So, yep. I mean, there's, cool. So yeah, we have a balances transfer, which is pretty lucky on this one. So we could show it. You'll have all these basic arguments, signatures, these args for the actual transaction, what the tip was, and then this is where the fees come in. So like, what is this partial fee? And partial fee just means it doesn't include the tip. Cool. And that's kind of running Sidecar and what it's like. And as you can see here, that transaction went through. And usually, what's interesting too, the first transaction you have for runtime, so if you haven't queried anything, might be a little larger than the rest because we're caching all of that metadata and runtime information.
Of course.
Cool. So
amazing.
That's Sidecar.
Yeah, hell yeah.
Awesome. Sweet. So we can exit out of this and let's go back here.
Let's back up. LA Ramon. Does that answer our question of what is Sidecar? We've just done our demo of it. We're about to move on to another tool. Before we do, does anyone have any lingering questions about Sidecar before we, on to the next? Can I customize the cache policies?
So as of right now, no. There is no everything. You could still cache things. I guess you can cache things on your end if it comes to like what individuals or what you're querying with like an Nginx in front or something like that. But in terms of Sidecar's cache policies, a lot of the caching happens on Polkadot.js itself. So it won't be reachable. It's kind of the summary there. But if there is something that you want, then we're more than welcome to add. This is a good question. Any plans for adding GraphQL support to Sidecar? So actually, no. We've had discussions about this before, and we do know that GraphQL is kind of it's a big tool in the ecosystem. I think there's a good time and place for it, especially when it requires talking to your client. So like having some front end talk to Sidecar, right? And you can have some standardized schema between the both of them, but that's not really what Sidecar was initially intended for. It is more of an indexer than it is a backend server.
Yeah,
So I think that's a good way to distinguish what it is, but we are open to PRs and discussion in the issue. So if it is something that's really big, we'll always discuss it and give it a fair shot.
totally. Cool.
Sweet.
All right.
So the next one, TX Wrapper Core. What is it? Cool. So this is a lot of words here, but I guess to sum it
Sorry.
up, it's a suite of packages, and these packages allow chain builders to build their own offline transaction construction libraries. And it comes with a plethora of helper functions. Not all of them will be useful for everyone, but
Right.
they might. And this is really cool, and I'll give an example. So let's say you're a parachain like Akala, for example, and you have
Okay.
a lot of um, extrinsics that aren't inherent to Substrate, but are really specific to your chain. Well, we'll give you all the tools necessary for you to build a very simple function for that extrinsic so that people can generate this online or offline.
Mm,
So, and I'll show in our code walkthrough and demo what that looks like. But generally speaking, this is a tool that you could use right away for Polkadot Kusama West End. So you won't actually have to do any configuration yourself. You can just pull in a library. Or if you're a parachain and you want to have some very specific logic for offline generation, you can pull in our tools and then make a library pretty easily.
yeah, that's pretty cool.
Sweet. And what are these packages? Cool. So these are the list of them that are exposed to users: Core, Substrate, Polkadot, Registry, and ORML. And we'll kind of run through what each package does.
Okay.
Cool. So TX Core, this exports all the methods required for constructing and decoding transactions. So whether it's a signed payload, unsigned payload, U8A to a conversion for your payload, anything like that will all come from this library.
Okay.
And same with decoding. Um, it also provides all the base functions for like metadata creation, registry creation, and method decoration. So this is pretty cool because like for our metadata, for example, let's say it's really important for offline generation to have a smaller metadata size because you're passing large metadata files if not. So we actually give these helper options that allow you to minimize the metadata to exactly what you need while also maintaining the integrity of it. That being like, let's say you only wanted systems and balances palette within the metadata itself. We can strip everything that's not important out so that the size of the metadata decreases by like 95%.
Oh, that's so cool. Yeah.
And for registry creation, that's to ensure we have the correct type registry set up so that Polkadot.js can read
Mm-hmm.
anything that comes in and create these types for you when it's time to construct the transaction.
Okay.
And we also give a suite of utility functions, such as like being able to derive an address. It only supports ED25519, ECDSA, and then SR25519. And that's just by giving your cryptographic public key, and it'll be able to derive the address for you. And then you can also import your private key to create a key ring.
Sweet. Berto, hello. Welcome. So happy to have you here. To not forget to mention the new dev faucet that we have.
Ooh, cool.
Yeah, we'll check that out actually. We'll pull that up too. Thank you for bringing that up.
Nice. Cool. So and now we have TX Wrapper Substrate. This is a very simple library. It basically just takes all of the extrinsics and methods that are public inside a Substrate and exposes them to users.
Okay.
So they don't actually have to build these themselves. And most other nodes or parachains might have quite a lot of these already.
Yeah. Yeah.
Cool.
Substrate, Polkadot. Oh, okay.
Polkadot.
Yeah, next.
Cool.
Polkadot.
So this is the actual package that you could just pull in, and it'll have everything you need to start building or constructing transactions.
Okay. Okay. Got it.
Cool. So yeah, so TX Wrapper Polkadot will actually take in core, it'll take in substrate, and it'll take in registry and expose all of that to the user.
That makes sense.
Cool. So and this package really provides support for Polkadot, Kusama, West End, State Mine, and Statement. So that's really the core of this, and it's all built parity-based nodes.
Sweet.
Cool. And yeah, so So this is TXWrapper Registry. TXWrapper Registry just exposes registry functionality for users, so they don't have to pull it in from core if they don't want to. It's very
Makes sense.
specific and adds some nice helper logic to it.
Yeah, got it.
Cool. So, and then we have TXWrapper ORML. We don't actually add too much to this. We add when it's like asked or specified in an
Okay,
issue. But this is a community maintained collection of runtime modules.
right.
And yeah, so we support a few methods in here that aren't supported in Substrate, but in ORML, and we expose that. And if users want to use them, they can. And if they have any wants or needs, yeah, just file an issue and we'll add it in there. But we don't stay up to date with ORML because it would be a lot to keep up with.
Yeah, but good call to action if someone, yeah, needs.
Yeah, exactly. Cool.
Yeah, demo time.
So let's actually bring this up really quickly. This will take a second. Cool.
Nice.
And then we'll increase this text a little bit.
Perfect.
Cool. So before we start running anything, I'm going to go through the examples really quickly, or one example, and just show you what this looks like. And then after this, then we can actually run this example and show you how to run it. And if anyone else wants to start hacking on this, they can totally just pull these examples down and start playing around with them and see if it fits their needs.
Perfect.
Cool. So such as with anything, when you're dealing with key rings in Polkadot.js, we have to add this crypto wait ready. That's just to ensure the WASM files are ready to start playing with the keyring. So in this example, we're just using Alice. So we just created an Alice keyring in order for us to apply that sender to our transaction. Now, I guess this is kind of important, but this is an offline library. But just as an example, we do actually connect to a node via RPC so that we can get certain information so we can attach it to the payload.
Yep.
And in this case, this is all the information that we're getting. Bit necessary just to have so that we can actually have an example. But let's say you are doing an offline library, like you're a wallet or some sort, you can always use QR codes or some way like that to actually have that offline pattern.
Okay.
Cool. And this is the registry I was talking about. When you're creating a registry, you can add this as calls only arg, and this arg will actually strip the metadata down. And then there's actually another argument that is called as specified to calls only v14, and that you can actually specify the only palettes you want. So either option works. One is a little more in depth than the other.
Fair.
Cool. So this is actually what it looks like when we're generating a transaction. So we have this unsigned transaction here, and it's under methods. And methods will contain all of these palettes for us, right? So we'll have balances, utility, proxy. And then under there, you can choose which palette that you want to use. And then that palette will expose all of the functions available. Cool. And then under there, that first argument is just going to be the args needed for that actual transaction itself. In this case, for transfer keep alive, we have the value and the destination. And then we have the payload arguments here. So this is just all that information we got from the RPC to local node. And then we attach some metadata and registry information to it to ensure everything is correct.
Fair. Okay.
Now to the decoding functionality. So we have this one decoded function, and this decode can take in an unsigned transaction, a signed transaction, a signed payload, whatever it needs to be. And we give some examples on how you can log that out to the actual terminal just to see what's going on. And cool. So we decode that unsigned transaction for you so you can see it, and then we actually build a signing payload here. So we have this construct function, which will take that unsigned transaction we made for transfer keep alive, and it'll create a signing payload. And then with that signing payload, we decode it again just to show that you can still decode it using that same function.
Yeah.
And then what we do is we actually grab the signature. There's multiple ways to get a signature here. There is no one source of truth. You can do what you like, being that it's an offline library, whatever you want to do. We just have this helper function called sign with here to show to users. And yeah, we just add Alice, the signing payload, in order to get the signature for it. There is a very useful function in Polkadot.js called signature verify, and it comes from util crypto. And if you ever want to use that to verify your signature, you totally can.
Okay. Great.
Cool. And then we're actually going to create that signed transaction here. And then from there, we derive that transaction hash of the signed transaction offline. And we show that. And then this is the actual hash that we expect from the node when we add author submit extrinsic.
Sure.
And then you can decode that information, and that's about it. So
Yeah.
it is quite a lot here in terms of code, but that's because we're kind of showing all the available avenues you can
Yeah,
use.
exactly.
But it could be a way less involved if you're just making it pretty simple.
Yeah, it depends on, yeah.
Yep.
That's up to you.
Cool. So I'll do a quick we'll run this and see what it looks like.
Okay.
So the first thing we need to do really quickly, let's just launch a little Polkadot dev node. And I guess we don't need to see this text here. We could just let it run, and then
Sure.
we're going to go here. Cool.
Okay.
So
Perfect. Thank you.
So these are this TX wrapper check is just going to actually run the example we have. We have multiple examples in there. We have some with balances. We have other ones with multisig, etc. So in this case, I'm going to run two examples.
So if I go, where would I find those examples? Sorry.
Oh, cool. Yeah. So when you go to the TX wrapper core repo, you just go to packages, and then there's a TX wrapper example package there that you'll find.
Cool. Awesome. Thank you.
And yeah, so this is just going to run that Polkadot example as well as a multi-sig call example. Sure. And kind of show you what the output of something like that example would look like.
Okay.
Oh, sorry. I added a signature verified to that, so we need to remove that really quickly. Cool.
Okay.
Cool. And as we had all those logging information below, this will show all of that, and it will give you a step-by-step as to what's actually going on. And if you'd like to log it run it yourself too, we kind of try to add as many descriptions as possible to kind of ensure you see what like the steps are that's happening. Cool. Yeah. And then if we wanted, technically, we could go query this node and see the actual transaction itself. Awesome. So that's it for TX wrapper core.
That's for TX wrapper. Okay, amazing. Yeah, let's pause before we go to our final one, final tool, to see if we have any questions. That's an awesome demo, and use cases are super clear. So yeah, but yeah, if folks are curious or want to get started themselves, please let us know. Otherwise, yeah, we can go into the preview, if you will.
Cool. And actually, as a side note as well, I think TX wrapper is really cool for like educational purposes too. So if you actually want to see what the construction of the transaction looks like and what that means, then you can actually just use this to get a better understanding of what's going on underneath.
Exactly.
Sometimes it can be a little tough looking directly at the Rust code and trying to navigate through Substrate. So having like some kind of centralized source of truth is nice sometimes.
Yeah, absolutely. Just giving you a little bit more detailed information. Yeah, 100%. I think when you're in that like beginning journey stage of things, why not have more help?
Exactly. Yep. Cool. So let's do the asset transfer API. Now, to give let's give a brief understanding of what it is, I guess.
Sure.
So it's a TypeScript API aiming to provide clear and simple to use tools for transferring assets across chains. And it aims to make StateMine and Statement the main hub for asset management in the Polkadot ecosystem. And why this is super important, right? Because XCM is really difficult to learn and understand. And it's really difficult to construct these XCM types, especially if you don't know where to start. And also, there's a lot of logic, like specified logic. So you might have a transaction or an asset you want to send from, let's say, StateMine to Karura. Well, that might involve a different type generation than sending, let's say, from StateMine to Polkadot or StateMine to Kusama. So it can get really complicated, and there's quite a lot of edge cases, and we cover them all in this API to allow it to be super easy. All you have to specify is like, hey, where do you want this asset to go? What is the actual asset you want? And what is the amount you want to send? And to which address? And then that's it. We'll take care of everything else. We'll give you the call data, payload, or whatever it is you may want. And then, yeah, you can send that.
Okay.
Cool. So let's actually kind of take a look at what it looks like. So we'll actually write this all out in a little demo at the end, but let's
Sure.
actually talk about like what's actually happening here. Um, so we have this asset transfer API class, and that just digests an API promise from Polkadot.js, and
Okay.
that's so that we can create a WebSocket connection and be able to get certain data we need to create these types with the metadata, create this registry, and then also get like regular data such as a spec name and a version and all that.
Okay.
And yeah, so you see this A equals await. Inside of there, it takes a bunch of args. That first arg is just going to be like destination chain ID. The second arg is going to be the address we want to send to. That third empty array, that's just going to be the assets or tokens. And in this case, we're actually sending it from a relay chain to state mine. So there's a little trick we could do in the asset transfer API where you don't actually have to plug in any asset because there's only one asset that's possible. In this case, it would be the native token. So if you're sending
Mm.
from Polkadot, it would just be dot. There's nothing else we could send. You can also specify dot in there too if you want to have like
Yeah, yeah.
this more specific tooling on your end. But yeah. And then the next would be amount. And then we take in a bunch of options. Cool. So
That's
let's
so
actually
cool.
talk about what these options are
Ooh,
and what
sure.
they
Yeah.
mean. Cool. So we have this first option, which is like a format. And this is specifying what you want to send. So it's a payload, a call, or submittable. And we'll touch more in depth on this in a future slide.
Okay.
And then there's this pay with fee. And this is the asset ID to pay with fee. So these two are actually going to change, pay with fee and pay with fee too. So I would,
Yeah.
these two are very subject to change. So I wouldn't be, and we're developing pretty actively on them to
Sure.
make it
So
more
yeah,
clear.
keep in
And
mind.
so, and the reason why is because we noticed the actual naming can be a little difficult to understand. Like pay with fee two sounds like we're paying it specifically to someone, but we're actually not. We're paying, we're choosing what fee to use at the destination to pay for the transaction. So the naming's a little weird.
Okay, yeah, no, that's not, yeah, that's not intuitive, is it? Okay, I get
Yeah,
it. I get the desire to like revise. So yeah,
cool.
stay
And
tuned.
and as a note as well, we're in alpha. We're right about to be in beta, actually, probably by
Exactly.
the end of this week. So things are rapidly moving and ready to change. But I would say for the most part, most of the things, except for these pay with fee options, are concrete and staying. Um,
Okay, okay.
so this is limited
Mhm.
option has to do with is the transaction you're sending or this XCM call limited?
Yeah,
And there's two types of XCM calls for transfers. We have teleport assets and reserve asset transfers.
right.
And both of those could be limited, which means is what's the weight limit attached to this actual XCM message?
Sure.
Uh, and let's say you attach is limited, but then you don't put in a weight limited, it'll actually be unlimited. I know it's a
Oh,
weird caveat.
fabulous. No,
It's a
no,
little
no, that makes sense
caveat,
actually. Yeah.
but yeah, so it's just part of the XCM construction. Um,
Hello, Jafar. Welcome back. Happy to have you here today.
hello. And then, yeah, then we have this weight limit option, so you can actually attach the weight limit if you want. Um, and then we have this XCM version. So XCM version means like what XCM version do you actually want to construct this? Let's see. Naming is always difficult. Oh, thank you. I appreciate that. I think that's
Yeah,
really the
right?
goal. Yeah, that's
Absolutely.
and it's
Good
super
feedback you're
important
getting
actually.
today.
Yeah, I love it. It's
Right.
really important too to actually give people these abilities to interact with the network without actually having to dig so deep into Substrate because it takes a lot of time and effort and can actually push people away sometimes. So
Absolutely.
it's a good intro into actually being able to send XEM transactions and feel like you're actually joining the actual network itself without having to dive deep into the weeds of things.
Yeah, you're in the business of making it like accessible quickly, I suppose.
Exactly, yeah.
Love it.
Um,
Love it.
So this XEM version is actually really interesting because we've had discussions about this on the team and how we want to deal with it. But
Okay.
so far, we're going to choose to support two XEM versions at a time until there's a new version.
Okay.
So
Okay.
so currently we're just supporting 2 and 3, and when version 4 comes out, we'll support 2, 3, 4 for an easy transition for folks. And then once all the network changes to 3 and 4, we'll only
You'll drop
support three and
too.
four.
Got it.
Exactly. And that's
Got
how
it.
we kind of do that leapfrog.
Okay.
Um, cool. And then we have this keep alive. And this is really only for local transactions because the asset transfer API will also handle local transactions for you on any system parachain or relay chain. And what this means is this keep alive will just attach it. So instead of having a transfer, you'll have a transfer keep alive.
Okay.
Cool.
Fair.
Sweet. And let's actually talk about the dependencies and why this is important for us. So we try to keep this API as lightweight as possible. We don't want to add extra bloat, and we want to do as much as we can in-house as possible. So there's only 2 dependencies for this API, and we know how it can be in NPM and Node, where you have this like library, and then all of a sudden you have like 10,000
Of course,
like libraries attached to it. So we want to be as lightweight as possible, and what that means is we only take Polkadot API, and we only use this in-house registry we built called Substrate Asset Transfer API Registry. And for the Polkadot.js API, we really just focus on using this WebSocket connection to query the node. And then we use its type generation to be able to make or generate these XCM types for these extrinsics. And that's really about it.
Got it.
And then we have this Substrate Asset Transfer API Registry. Now, this is actually super important. It's a zero dependency library, which means it exposes nothing but this JSON file for us. And this JSON file is what stores all the source of truth for all the parachains and relay chains, or I should say all the relay chains and their parachains and the tokens and assets they hold. Right. So that we can actually be able to see and verify the information you're passing in and be like, hey, is this correct? Or maybe this token doesn't exist. And what's really important about that, we don't want you constructing XCM messages and have you transmit them and potentially like have a fee taken from you because it was constructed wrong. So there is this idea that we want to make sure from beginning to end, everything is correct and perfect for the construction of your message and transfer.
Mm-hmm.
Cool. Sweet. So let's actually just talk about the structure of this a little bit. It's very simple. We have this at Polkadot key, and under that key, we have a bunch of numbers as keys as well. And those numbers just reference the parachain ID. So like 1,000 there, for example, statement, and then you'd go to 2,000, which would be Karura, so on and so forth.
Okay.
And 0 is actually what we use to identify the relay chain. So if there's any information for the relay chain, we put it under 0 so that we can also grab that information.
Yep.
And so this is built on a script that we have locally in that Asset Transfer API Registry repo. And we understand that it's not perfect in the sense of all the data we get might not be currently available because we pull from a registry inside of Polkadot.js apps. And let's say a parachain doesn't have all their info in there. We allow them to actually inject it themselves. So like, let's say you have some tokens or something and you're under Polkadot. Well, you can totally inject all that information and the registry will then add it. And then you can identify that within your XCM construction.
Cool.
Yeah. Sweet. So let's actually talk about this API promise and the asset transfer API itself. The asset transfer API digests an API, or this Polkadot.js API, which is called an API promise. Now, you can construct it yourself, and that's totally fine. And then you can just pass it in. But we also noticed that sometimes people don't want to actually have a Polkadot.js API dependency because then it might conflict with our dependency and they always have to match the current versions, right? Their version might have to match our version, and the reason why is there might be some conflicts between versions. So we actually expose this construct API promise for you so that you don't have to have Polkadot.js at all, and then you could just build the API that way and then pass it in, and then you'll be dependency free in terms of Polkadot.
Sure.
Cool. So let's actually talk about a little bit of the workflow, like what happens underneath the screens and why is that important? So we start with this API promise, as we mentioned, and then it transfers to this asset transfer API.
Yep.
So in the asset transfer API, most users are going to call this create transfer transaction because that's really the core and meat of things. And then from there, it's going to declare a transaction or XCM direction. Now, this is super important because this says, where's the origin and where is the destination of this transfer that we're making,
Right.
and how does this matter in terms of our XCM construction. So from there, it chooses, is this a cross-chain transfer or is this just a local transfer?
Okay.
And then it's going to all go into something that we have this input validation and error layer. And now this is like probably our most important part to make sure all the information you pass in is either correct or incorrect. And then we'll let you know and ensure that you don't construct this transaction. And we'll
Okay.
actually have very in-depth and meaningful errors so you know exactly what happened and what to do with the mistake you had.
Okay.
Or mistake on our end, right? Because sometimes bugs do exist. So
Totally. That's fair.
it'd be good to catch them. And then from there, it's going to either construct the XCM transfer or construct that local
Local, yeah.
transfer.
Yeah.
And then it's all going to return a format that you specified in the beginning of that option. If you didn't specify, it'll just be that default payload.
Sure.
And yeah, and that's it.
Cool. Yeah, that's helpful.
Cool.
I was
So
intimidated when I first saw the flowchart, but it makes sense.
yeah, it was a little difficult to fit it all in in one page. So glad
No,
glad
that's
I was
okay.
able to do that and
You did.
kind of
You
make it
nailed it.
so simple. Cool. So let's actually talk about these XCM directions a little bit
Yeah.
more.
Sure, sure, sure.
Um, so as I mentioned, it's about where's this origin of the transfer that we're generating and where's the destination. And this is like really important in terms of our code quality because things can be very messy. We don't want to
Mhm.
actually couple a lot of our logic for this XCM type
That makes
generation.
sense.
And we want it to be able to clean so we can identify bugs or just allow to maintain this over time with XCM version increases pretty easily. So we've actually declared these 7 main directions. I actually guess it's 8. I added one more this morning. um, cool. So we have a system to relay. So that's just a system parachain to a relay chain. And
Sure.
that's fully supported now. We have system to para, which is currently supported as well. And then we have this relay chain to a parachain, which is supported, and relay chain to system parachain, which is supported.
Okay.
And
Okay.
these you can build today and construct these, and they're totally fine. The other 4 that we don't support yet, and it's actually because they're more so very complicated, and we want to ensure we get them right, is para to para, or para chain to a relay chain, para to system, and a system to system. Out of those 4, para to relay is probably the easiest, but it kind
Okay.
of shares the same complexity. And the reason why is parachains might have different palette naming for their palettes. So
Exactly.
like
So how do you?
so we actually have to construct a registry to be able to
Okay.
identify all these
Okay.
or be able to like actually like scrape through these
Yeah.
palettes and be able to find it. So that's like what's really tough. And
It's an interesting
everything
problem.
yeah, everything else is kind of solved. We just need to have this some type of registry for what
Sure.
they use.
Okay.
And then that actually might involve some community support where we ask
I
parachains like
love that. Yeah, it's kind of what I was thinking. It feels like an opportunity there, huh?
right where we could just ask and be like, hey, if you want your parachain supported in our API, you have to add your
Yeah.
config or whatever it might be inside of our registry, and then we can identify exactly what it is.
Yeah.
Um, cool. And then it's just the system really has a lot to do with bridges. I can't go too in depth with it yet because I haven't really understood the complete depth of the problem. But as bridges roll out, we'll have to support transfers from different system parachains.
Jafar has a question. I'm not sure I totally understand it. Payment process and substrate unique palette.
Are you talking about NFTs?
Yeah, I'm
I
wondering if that is this. Yeah, maybe we next episode should probably we could probably do a whole thing on NFT palettes. Oh, and you also there's been a Friday episode. I think there's a YouTube video recently.
Yeah, there was a deep dive on the Uniques palette NFTs. Currently, we won't be supporting NFTs, and I think because we really want to just focus on sending assets themselves.
Yeah,
Um, but is it something that's out of the question for the future? Absolutely not. It's a completely different beast to handle,
exactly.
and I think that yeah, once we nail this whole entire asset transfer down,
It's the
then we
next
can
phase of
add
it. Sure.
yeah. And I think the reason why is that's actually great you mentioned it is on the actual XCM construction part of it, there's this fungibility field. And that fungibility field can also be a non-fungible field. And
Ah,
the
yeah.
issue with that is it actually also matters how your assets are ordered when you send this
Hmm.
message. So if you're sending multiple assets, that NFT will actually affect that order. So that's
Yeah.
one thing we'd actually have to keep in touch. There's a lot of little edge cases. So it's definitely something we won't
Interesting
tackle
though.
yet.
For sure. And then Jafar, you also asked an ink question a little bit ago. We actually have an ink office hours happening tomorrow on Twitter Space. So, or Twitter, we'll be having a Twitter Space for that. So please join. It's at exactly 24 hours from now. So yeah, please join that.
Cool. And as a side note too, in Sidecar, you can totally interact with contracts and query any
Yeah, I'm glad you
queryable
said that.
storages in it. Yeah,
Yeah, for sure.
cool. So let's actually, there's just a few side notes that we can cover here about the
Sure.
creating transfers. So currently the API really just supports Polkadot Kusama West End. Um, and it doesn't really support Rococo, and there isn't any other relay chains I really know about. So I don't think that's too big of a deal, but it is just something to note as well that those are the three relay chains and then all their parachains. Um, and the API regularly recognizes the relay chains with an ID 0. So if you are sending an asset from, let's say, like statement to a relay chain, the destination ID is going to be 0. And that's kind of a source of truth across the whole API.
Sure.
Um, yeah, so in the system to para direction, we really focus on supporting multiple assets. So you can actually send multiple assets. You cannot send multiple assets that are foreign and native. So they would all have to be one or the other. And the reason for that is the way the logic works in terms of the extrinsic palette you need to call. So for native, it's going to be a teleport, and for foreign assets, it's going to be a reserve. So we can't
Yeah.
mix them all up in the same call.
Okay, good shout. Good clarification.
Cool. And what's really neat is the API is smart enough to recognize between the transfers that you need, and the return result will tell you exactly what call we used so that you can verify it yourself.
Sure.
Cool. And then I think I touched upon this, but like every XCM direction has its own nuances. So the API really treats each direction as its own module logically. There's no coupled logic between any XCM direction. They all are separated.
Okay.
Cool. So we can do this really briefly, as we touched on it earlier, but there's really two types of local transfers. One is for assets, and then one's for balances. Um, So you'll only really have this nuance when you're on a system parachain because you can really transfer assets locally or balances locally. So you
Right.
might have an assets transfer or balances transfer. We'll recognize that for you. But for relay chain, it will just be balances transfer. And then one note to have is there's a recent breaking change in runtime 9420, which changed transfer to transfer allow def. So there's a 3-month grace period from when that was released for users to switch over. So we'll actually be handling all that, but that's just something to take note
A
in.
good
And
note.
yeah,
Yes.
and same with TX Wrapper Core as well. So that'll be changed when it's due in TX Wrapper
Of
Core.
course. Okay.
Cool.
Oh yeah.
So let's actually go over what this return looks like. And I apologize if the text is a little small, but
That's okay.
so this is what the return looks like from a create transfer transaction. We have 5 fields here. So we have the direction,
Mm-hmm.
and this is to allow the user to understand what was the flow of this XCM transaction, kind of
Yep.
origin destination,
Yep.
and then the XCM version we used. What is the actual method that we use for this? And then this format that you specified to return that back to ensure the user can verify that, and then the actual transaction that they're going to sign and send.
Cool.
And kind of to go over these formats a little bit. So the first one we have as a call is just going to be returned as a hex string as well as
Yep.
payload. And so what actually makes this super interesting is we actually also return a submittable. And what does that mean? So in Polkadot.js, there's a submittable extrinsic type. And this submittable extrinsic type has a bunch of functionality attached to it, such
Ah,
as,
cool.
yeah, so you can just sign and send
Yep.
automatically via this submittable instead of
Okay.
actually having to do it yourself. So you have kind of both options. You can either do it
Yeah, I love
yourself
that.
or we can attach the functionality for you.
Okay.
Um, cool.
Helpful.
So we have some additional features as well. Not everything is create, transfer, transaction. You can decode the constructed extrinsics that you have. You just
Mhm.
plug them in and it'll decode it for you so you can verify all the information.
Okay.
And you can see exactly how the XCM was constructed too. Um, then we have a fee estimator, so you can actually also estimate the fee of these extrinsics that you're
Important.
building.
Love.
And and then an additional feature that's being actively worked on as well is this registry expansion. So
Hmm.
you'll be able to actually look up into the registry and have quick lookup times to verify the tokens for the chain, or if your chain exists, so on and so forth. Just so that you
Okay.
can actually see like, hey, I'm going to construct this transaction, but I want to actually see if the token exists on this chain.
Yeah.
Cool. So kind of I mentioned this earlier, but like what's next for us? So we're
Yep.
still in this alpha phase. We're right about to release our stable beta version, and that will be
Hmm.
followed by a V0.1.0 release soon too. Um, Things are actively being developed on, as I said earlier, so there might be some changes here and there. Um, and if you want, please follow along on the repo itself to see what's kind of happening.
Yeah.
Uh, and as we push towards a stable release on our team, we're really big about conventional commits. So you'll see very verbose change logs and up-to-date releases, which will be pretty good.
Love it.
Um, cool. So let's actually just write some code really quickly and see what that
Do
looks
it.
like.
Yeah. Let's have that demo.
Cool. So let's see, asset demo really quickly. And we're going to do this completely from scratch.
Okay.
Cool. So let's see where we are. Rad. And let's do an npm init -y. Let's just get a package.json here really quickly.
Sure.
Let's do an npm install at substrate asset transfer API. I spell that correctly? Yep.
Yeah.
Cool. Sweet. And let's just ensure that our package.json has the package. And sweet, we can see that it's the alpha 4 version.
Okay.
And then let's touch a quick index.js file. And then we can hack away on this.
Great.
Cool. So the first thing we need to do is we need to add our functions to this. So we can quickly require, and let's add the asset transfer API and the construct API promise.
Quick question on why you're using npm versus yarn as you did earlier.
Yeah, of course. We're just using npm here because it's really quick and easy to just get it up and running. I kind of just change between both. If it's
Interchange.
actually,
Yeah.
yeah, if it's an actual big project, I stick with Yarnberry just because for development reasons, it's really fast. They have a lot of like plugin functionality, which is really good. But in this case, just because we're doing a quick demo, I'm just going to use npm to not complicate things.
Yeah. Yeah.
And just to like clarify as well, there's like two big versions of Yarn. I don't use Yarn 1.x. So like if we were to use Yarn in this project, it would have to be Yarn 1.x, which I don't use, just because it's not really up to date other than security updates.
Right.
But npm is. So it's like one of those things where it's like depending on the situation.
Exactly.
So let's create a quick main function really quickly, and this is just so we can call it. We'll do main.finally, just so the process can exit correctly. Cool.
Okay.
So I think the first thing we need to do, right, is let's construct this API really quickly. And also let's add a top layer async. So let's do API equals construct API promise. And we can see that the API promise takes in a WebSocket URL and then potential options if you want to pass in if you are more advanced and understand the API promise itself. But we really have nothing for this use case, so we could just pass in, do Polkadot really quickly.
Sure.
And then the one thing that we need to do with the API is we need to await and say API.isReady. And that's just to ensure, oh, and then we need to await this as well. Cool. That's just to ensure that we don't start calling the API before it decorates everything that it needs to. Cool. Now we can make this asset API. And we could just say new asset transfer, and then we can pass in this API itself.
Cool.
Sweet. So this asset API now we can use this to create a call. So we could say like const call equals asset API dot create transfer transaction. Let's assume that we're going to just be sending a transfer from Polkadot to like statement. So that would be chain 1000.
Okay.
And then from here, we would actually just pass in any random address, not a random address, but the address you want. But in this case, we'll just pass in an address. Actually, this is actually a Western address too. So we'll actually just write Western just to ensure everything is aligned. And then from here, we want to add the asset IDs, but because we know it's from a relay chain to a system parachain, we actually don't need to add anything. And then we could say the amount we're going to send is probably, I think that's about 10 right there, 10 Westies. So when it comes to our options here, let's do format is call.
Okay.
And we can kind of see the difference between both of them. I'll show submittable as well.
Sure.
And then we'll say this is limited. We'll say it's true, but let's make it an unlimited call.
Oh, fun.
And then for the XCM version, let's do 3.
Cool.
Sweet. And then for clarity, we could just console.log what this result looks like, or cool. And then we can see, and let's run it really quickly. There's an issue. Oh, right there. Cool. Sweet. So let's just do a node index.js. Oh, the promise is pending. Let's see really quickly. Oh, wait. Cool. Rad. And are we const.logging the correct thing?
The call.
We are. Let's do some live debugging really quickly.
Fun.
Huh. So that is all correct, I believe. Let me just see what is the address incorrect? Nope, the address is correct.
Okay.
We're passing this in. The API itself is correct too.
Okay. Then your call, you added the await. And so we have a default that it's system to, what was it? System to,
Did I write anything wrong here? I have another example that's like identical to this right next to me. Is it main.finally?
That as you wrote
it.
that.
Interesting. Do you know what? I'll just take the example I copied earlier, and we can actually just do this and then see what the actual difference is.
Yeah, let's just compare. Okay, so
let's see if this actually.
Oh yeah. Okay, sure.
Oh,
okay. Go back. See? Let's figure out what the difference was. Hold on. Let's see here.
The only difference I can see is the XCM version is different.
Yeah, you have 2 versus 3. Go to your commented one.
I guess. I don't see much difference at all.
Yeah. Okay.
Cool. Let's see if that XCM version is a difference, and that'd be good to look into.
And audience, if you see something that we're missing, please chime in. I love group debugging.
Yeah, see, it's still, there is still something.
Still. Okay. You're logging 0 in the second one.
Yeah, so we have 3 awaits here. We have 3. Yeah, it's the same. Huh.
But wait, sorry. The issue is the number.
No, I switched the number over to for the
sorry,
XCM
Aaron
version.
says that you're sorry, let me pull the yeah. It needs a bracket around in your first one. And how much you're
Rack
sending? Line
this.
13.
Oh,
Yeah,
yes.
that you
Oh,
need. Yeah,
thank you
you
so
need to wrap
much.
that.
Cool.
Isn't this fun? This is why I love doing live coding, because people are like, "Oh, it's right there." Thank
Cool.
you.
And that should totally right.
Yep, there
Sweet.
it is. Sweet. Thanks,
Cool.
folks. Love it.
And sweet. So we'll have a relay to system, a limited teleport asset, a call, all this. That's actually really good to know too, because in our validation center, we'll just add a check for that too, because that's not in there. So
Exactly.
that's really good to
Exactly.
find.
That
Thank
was
you so
nice.
much for helping. Sweet. So one thing to note too about this, so here for our type generation, we have a call. So it understands that this is just going to be a hex. But if we change this to a submittable, it'll
Yeah, that's what I
understand it's a
said.
submittable too, and we'll have all these, we'll have sign and sign async and all that attached to it, which is
Okay.
pretty neat. In TypeScript, you'll have better type generation, which is pretty nice, but being that this demo, we're just using JavaScript. Cool. Sweet. And that's basically it.
Wait,
Just to kind of,
can we see
yeah.
that? Do you want to run that?
Yeah. So we could actually write, I think a good thing for this, we could just do object.keys on the
Mm-hmm.
call
On
itself.
the call.
And then we could, it is a type registry type, so it might not actually show all the information.
Hmm.
Oh, we have to do it on the transaction itself. I'm sorry. So if we do call.tx, we'll actually have it all here. So we have this add signature, args args. So these are all the
Okay.
additional functions or getters attached to that submittable extrinsic.
Okay.
So like here we have sign, sign and send, sign is sync, sign fake, and
Yeah.
all that.
Oh, that's cool.
Cool. Sweet. So that's kind of it for
Awesome.
this. I'm really happy we found that one little issue because that's something we can
Yeah,
take
that's
care of
something you can
today.
bring back pretty straightforward. Yeah, I mean, I genuinely, I love live coding for that exact reason. And like the mind share that can happen from everyone looking at it together. That was an awesome demo. So it's cool to see what's coming up with that and get a preview of that as well. What's the timeline roadmap on that?
So actually, we're aiming. So we haven't done a release in a little bit. We're doing
Okay,
a big release either today or tomorrow, and
that's
it actually
exciting.
should have some validation for this layer right here.
Okay.
Um, but other than that, so we have a big release coming out with is Alpha Point 5. By the
Uh-huh.
end of this week or beginning of next week, we'll have a beta release. And then followed up by that on June 16th, we are aiming to have our full stable release.
Okay.
So yeah, we are
Cool.
currently doing more live testing between system parachains and parachains to make sure that that is all good now. But
Cool.
everything is stable between any system parachain and relay chain, which is really good to know.
That's
Um,
awesome to hear.
yeah, so we're slowly getting there, and it's sprint time, so we're definitely doing our
Well, thank you
best
for
to
giving
keep
us
up.
this your time today to share this with folks in that particular space you're in for your team. We really appreciate it. And of course, folks, we really appreciate you participating in today's stream. Again, our goal is to make this as interactive as possible each week so that we can answer your questions, understand what you're building, and really make sure that you are, as the community is at the forefront, and that our developer community feels heard, and we have a space for us to gather and to share our questions and also learn from one another. So thank you as always for participating in that. And Tarek, thank you for being a guest today. These were incredible tools, and I hope that folks are using, giving feedback, creating pull requests, and all those sort of things to participate in it.
Awesome. Thank you so much for having me. This was really fun.
Absolutely. Really, really enjoyed it. And yeah, bye folks. That's it for today. I believe the next episode of Substrate Seminar, a little teaser for you. Our head of engineer, Stefan is joining me too for the release of 1.0 for Polkadot. So should be fun to talk about all those sort of things. But yeah, for now, ta-ta. And thank you once again. I really, really appreciate you joining me. This was very kind of you to give all this time in such a chaotic coding time for you as well. See ya.
See you later.
Bye.